in Botswana and in Germany combined teaching and researching, so these cooperations. So these are the 4 ideas that are the base of our project. Then we need definitely a lot of simulation and do training simulation for students. We have to think about building codes. What is the standard of a building now, that we can not only improve one building, but what we find out what should be done with a building at least. So something like in Germany, we have a certificate or something like this exists in other countries too. So we see what is the standard of the building code at the moment, how do we develop. But these are all the ideas, and we say, okay, we have to focus on one building to show that it is possible, not only and put it into a concrete planning or concrete guidelines how to build something. And then Tobias has contact for several years already to the Okavango Research Institute, and there they have the herbarium in Maun. And this herbarium is something like, there is a real treasure with a lot of specimens in there which are not really properly stored, but which should be, from a sustainability point of view, restored for mankind, because there's some plant specimen in there which do not exist anymore. And this treasure needs a real treasure case. And we want to say, okay, let's do the planning for this treasure case. And it should be energy efficient. We should have solar air conditioning, and we want to have it sustainable in a broader approach. And definitely, this is a flagship project, but it also, if it works in one building, it can. There's a planning for a whole campus, so it could work also on the whole campus, and it, as it can. Knowledge should be distributed into all non-residential buildings in Botswana, the research that we do. That's the basic structure of our idea. It's not a project. Maybe finally the project will focus much more on sustainability and less on air conditioning. Also here we started off, this will be maybe, or the other way around, it will be all about energy efficiency and building codes. That we don't know. We just, opportunity seekers. We have to where we can get funding, where we can cooperate. So these are just some sort of bricks we are building a project on. Which brick we use more often and which one we use less often will be finally decided. So just about the bricks. So solar air conditioning, what do we want to do? So solar thermal systems that you can use for air conditioning. That's where Tobias did his PhD, where I do some work in my laboratory on. So evaporative cooling you can do. You can desiccant evaporative cooling. Interesting systems, but hardly seen in Botswana, maybe inside labs. So we will have a look at it, but more we will look on PV chiller systems. So just chillers, how we hear them here, or how we see them everywhere, can be driven by PV, but the combination of PV and chiller can be optimized. And then we have a huge cooling load when there's no sun anymore, so we need some storage. Do we store with battery, or do we store with a cold storage, just cold water? Yeah, but we have only air-driven system in many buildings, so that might be a case too. So these are topics we are going to look into, and finally want to come up. Every building is different, but if you can characterize a building, this and that building, that would be an ideal solar cooling system for this and that building. That's the aim in the solar air conditioning section. Sustainability is a huge field. So normally you always have this social sustainability, economic sustainability, and ecological sustainability. As I work a lot with architects, I think they always think there must also be some cultural sustainability, not only as part of social sustainability, we need also this. So what does it mean? Social sustainability means that we have to integrate our users and the community into the planning process. Very often buildings are planned without thinking about the users, and then it gets funny or very sad. So we have to think about this planning process. Cultural sustainability, so we have local building traditions, local materials. Economic sustainability here is low investment costs, but more important also low maintenance costs and low energy costs. And last but not least, ecological sustainability, low carbon footprint, low energy consumption, high solar share, and so on. So here we have so far looked on the solar side, the energy efficiency, and on the building material. So that's very grateful to have you here. That, for example, concrete is not really a sustainable material as it is used nowadays, because we have no sand anymore. So we're not going to build all the buildings we want to build if we do it in the same way as we do it today. And we have to integrate this in our project as well. So about energy efficiency, yeah, energy efficient chillers, yeah, sure, but that's not all. You have seen the Vienna University building. How did they manage to make a high rise of a university? There's a lot of work done into a plus energy building where you have a little roof only. That's because they reduce the energy consumption. Here is a standard computer, and that's what he's using in normal operation, and that's what he's using in standby mode. And then you have here, that's what they use at the moment. Then what you use, that's a standard PC of new standard. And if you choose to go for an energy efficient PC, that's what you get. And finally, if they found this one on the picture, who is just consuming 10% of a computer what they're using now and doing the same work. So, and they reduced 90% of their energy consumption for computers. They reduced also their cooling loads, and they also reduced their investment costs because this computer turned out to be cheaper than the one they normally buy. So it does not mean being energy efficient is something costly. It's the other way around. You save money. It's just there's a branch coming up in Germany and Europe, people who advise you what to buy that you consume less energy, because this is the simplest way of saving energy. You just don't buy anything. You buy something that consumes less energy. An even bigger example is what you have if you go into a room and an automatic control. If you enter the room, the light switches on because it's an infrared sensor who detects movement. And that's how in modern building, something like 300, I guess 3 to 400 of these infrared moving sensors have been implemented in the Vienna University building. And they wanted to use this one. And then they did a bit of research and they found one which is only using 3%. So a reduction of 97% of energy consumption in a small detailed thing, but that's used very often in a building. This reduces your energy consumption a lot. So then about building codes. You see what happened in Germany? Building codes were introduced in the 70s. And the regulations became stricter. Every inch, now you were allowed to consume this, and the first one you were only allowed to consume this. So this is always what our law requires new buildings to consume maximum. At the same time, we did a lot of research and how can we do this. So this is the curve down here, and you see you have to be in the research always way ahead of the regulation. And this is shown. And then reality of how people build something. They have to be better than that, but they don't do research, so they build something in between. So that's the energy consumption of every building going down by every year a bit further. So, and now we are already in the research area in the plus region, and we want to get a bigger plus, and we want to become, the more important thing is that the reality becomes a plus energy building. Not only few buildings, but every building should become like a plus energy building. So last thing is what we use is going simulation, and we want to do simulation in a way that, my flight here, that's quite an energy consumption too. That increases my personal CO2 footprint quite a lot, and I really had a long thought if I should do it, but I said, okay, I finally do it. But working together also, we should be able to work together without traveling around the world, because our mobility is mobility into dust. So we have to reduce our mobility. And so if we work together, we like to work together on a research platform where someone sitting in Botswana and someone sitting in Germany, they can work together on a planning platform and do simulations together. And last but not least, people are involved, and we have to have some cooperation and students exchange and teaching staff exchange. Also, it consumes energy. We need also some exchange of people. We have to think about it, if it's worthwhile to have this exchange, but we can't say, oh, we care so much about energy consumption, we can't talk directly to each other anymore. So here are some pictures from the NEET and the Air project I guess these two are in Ingolstadt, and this one is I guess it was in Zambia. I don't know. You have been taking part in Zambia. So. Okay, yeah, and finally we come to the last goal of our research project. This is a 10-year-old planning of the campus in Maun, and for us it's nice to have this as a flagship project, not only and also as a research project, because there exists a planning. We know what they want to build, but there's no actual pressure to build it to have results tomorrow, because if you want to research, you need some time and compare different ideas, and you can't do it if you want to start digging in half a year. So this is an existing planning, and we want to improve this existing planning in terms of efficiency, sustainability, and use of solar. And we want to start with the herbarium in there as our flagship project. But as I said, so far it's only an idea, and that's why I'm here to discuss the idea with you. And I'm grateful for any criticism or questions you have about this idea. So this is it, what it is at the moment. It's a herbarium where there is some air conditioning, but it's not a controlled environment as it should be for such an humanity treasure as these 30,000 species, which have been gathered with a lot of work, should be. Okay, this is it. I thank you for your attention and hope that you find my presentation.
Thank you, Professor Schrag, for that very wonderful presentation. Finally, we're online. So yeah, we're open for questions from audience here in the room as well as audience online. So, but first of all, I would like to say first that this series of activities was organized by Dr. Tobias Bader. I forgot to mention you, and he's the one who hosted Professor Schrag to come to today. And he's a very active member of our department, Mechanical, Energy, and Industrial Engineering. Let's give a round of applause. Okay, we're ready now for questions from the audience. We have to make use of Professor Schrag. He's here. He flew from Germany to be with us. Let's start with a crazy question. For sure, the students have crazy questions.
Let me start.
Yes, sir.
Your very last slide, you are using the master plan of Maun. Have you looked at the master plan of BIUST to see what can be done? I'm looking at the logistics. To, number one, to infringe on their privacy, all the problems, getting permission, discussing with them in my own meeting, etc. Have you looked at the master plan of BIUST, which exists, and we have a huge expanse of land here, yet undeveloped. We have Makoro next door. So many advantages around here. Have you looked at the possibility of developing a building, sustainable building around here?
We have I think that's a very good question. We haven't done so far because we're exchanging ideas, and we said, okay, we take this herbarium, which needs some housing and is a good representative for sustainability in Maun as a flagship project. We exchanged other ideas about taking an ordinary administration building of this university as well, but we thought we need a really good project. And I just learned yesterday that there exists planning for a herbarium here in the biology and science department. We didn't know that before. So as this is only on the idea stage, it might come out finally that if there's a planning and the willingness of the BIUST building administration body to design a sustainable building here, it might be a good idea to do it here as well. So we have to see how things evolve, with, where we get the best cooperation and what would be ideal for a flagship. If it's more feasible to do it here, Maun is an idea, an interesting idea. I don't want to abolish it immediately, but we are open to this idea and have discussed it. So we will get the plans about the herbarium as well.
I like the two words which you said as well, right? Because we must not think either or, right? We can do both. So maybe we start with one, because which is the most important in Botswana, right? Competition, which will one day maybe enrich the business environment for energy here. So we can already see, right, by starting in Maun, we created a competition for BIUST, and now there's a demand, and we'll do both sides.
Any other questions from the students? As you can see, we have some. Oh yeah, please introduce yourself and then.
My name is Jeet Parikh. I'm doing electrical and electronics engineering final year. And I have a few questions. When you started your presentation, you showed a picture of a house where there was a solar PV panel and solar thermal panel, which goes to the controller. Why are we connecting the thermal part of it to the controller? And what type of a controller are we using?
So in this research project, the controller type was not specified yet. We worked then together with a company building a controller. It was what should be the logic of the controller to take into account for the solar system will produce hot water, but it can be stored in a hot water storage, but not further. And the PV system can produce also hot water via a heat pump. But the PV system also can produce electricity fed in the grid. But you get less money for electricity fed in the grid than if you take electricity out of the grid to produce heat. So the controller needed to know how much the solar system is producing in heat, and said it knows, okay, I don't need to take any electricity out of the grid at the moment because the solar thermal system is already doing the job. I can, if I have some electricity for my PV, I can feed it into the grid. If it's the solar system signals me I'm doing a good job, but just so I can at least I tell my heat pump, don't take electricity out of the grid. If you have electricity from PV, then use it. Just this combined optimization has to be done by the controller. So the controller did have to know what the solar thermal system is doing, so that he can tell the PV heat pump system what to do. If the heat pump has to switch on or be off, if the PV is feeding into the grid or is producing heat with the heat pump.
And another question was, the thermal system, is it a direct system or is it an indirect system of water heating?
In systems, the solar thermal, it's an indirect system because in Germany we hardly use siphon or direct systems because we have cold winter. when our temperatures go way below 0, and so we have in our solar circle we always have water glycol mixture, so we don't get any freezing which would destroy our system, and that's why we always have an indirect system in Germany.
The last question, in terms of storage, we normally use batteries to store the power. Do you have any initiatives for to avoid the battery maintenance cost? Because the lifespan of the battery is hardly 5 years.
Yes, there's a lot of research done about batteries at the moment. So how to get the cost down, how to get the life cycle of the battery longer, how to use the battery so that it is lasting longer, but also what other kind of storages we have, because batteries are still expensive in